Hello everyone, it's 1 p.m. Eastern, and that means it's time to begin another of our monthly CoCoRaHS Weather Talk webinars. And today we have a special Weather Talk webinar we'll be telling you more about shortly. Hi, I'm Henry Regis. I'm your host today. I want to thank you for joining us. Behind the scenes, running the technical side of our program, are Zach Schwalbe and Noah Newman. We're coming to you live from the Colorado Climate Center here at Colorado State University in what has turned out to be a mild and dry day here in Fort Collins, Colorado. For those of you who are unable to join us for our live broadcast, we'll be recording this one for future viewing on our website. And all of our Weather Talk webinars are sponsored by grants from NOAA's Office of Education and the National Science Foundation. Well, today, folks, we're excited to have back with us our good friend Greg Carbon. Greg is the Warning Coordination Meteorologist for the National Weather Service's Storm Prediction Center in Norman, Oklahoma. There we go. Each year, Greg puts together a presentation on the top 10 weather events in the United States during the past 12 months. And if you've been at any weather conferences around the country, you may have seen Greg give these talks. He gives these talks to packed audiences. I've seen several, and then last year he did one for us here on the events of 2013. So you know, if you've listened before, you're in for a real treat. Well, Greg, welcome. It's great to have you back with us again this year.
Well, thank you, Henry. And let's see. I guess we're ready to go here.
Yeah, you know,
is that correct?
Indeed. Before we start, I've got a question for you. You've been doing these for, what, 10, 15 years now, putting these together?
About a dozen. This will be the 12th year in a row that I've put together the list.
Well, out of the 12 years, what are the most memorable events, the most significant ones, maybe the all-time one and maybe a second runner-up as you've been doing these? We're just curious.
Sure. Without a doubt, Hurricane Katrina has to take the top spot in terms of the meteorological memories. That was just a phenomenal event, meteorologically speaking. And second, given that I'm involved in tornado forecasting and severe weather, it has to be the April 27th, 2011 tornado outbreak in the southern United States. That would take the number 2 spot.
Wow, yeah, those were both of those events quite significant. Well, go ahead and take it away, and we will be back after your presentation with some questions for you from our audience. Thanks.
All right. Thanks, Henry. So, yeah, here we are, the 12th Annual Meteorological Memories Talk for CoCoRaHS this afternoon. Thanks for joining us. And I gave this talk back in October at the National Weather Association and seemed relatively well received. Without further ado here, let me just go over a couple of the rules as far as the presentation. These are my meteorological memories. I'm not attempting to rank any of them exactly right now, although we just ranked 2 of the more memorable events in the history of this talk. But as the year goes by, I sort of keep track of things, and I really don't start putting together the talk until around August, and that's when I start going back through some of the records and looking at the events and trying to put them into some sort of context, also trying to tell some sort of a story with each one. So your mileage may vary. There may be events that you think should be in here that may not show up, and then there may be events that you had not heard about either. So let's get started. With number 1 here, January of 2014 started off frigid across the Midwest, the South, and the East, and it's interesting to note that the 500 millibar large-scale pattern shown in the upper right there remained established for much of this year, and in fact continued into November of this year, which we'll talk about toward the end of the talk. And this pattern played a role in a number of weather events. When looking at the, well, I've got to close this slide here. Hopefully you're picking this up. When we look at the last few decades, though, how unusual was the cold experienced last January? I decided to take a closer look at the continental United States and the average values for the temperatures around 12 UTC every January morning back to 1979. And we'll take a quick look at how the winter pattern impacted the South toward the end of the month. And then in the lower left here is just the anomaly of temperatures during January 2014. So here's a calendar of daily temperatures, essentially low temperatures of January 2014, and the maps show the actual North American regional reanalysis surface temperatures at 12 UTC, which is usually around the time of the lowest temperature of the day. So this was January 2014 calendar. On this calendar, we see that there are 4 mornings that were among the coldest 5% of January mornings over the last 36 years. January 6, 2014, having a continental U.S. mean temperature of about 16.5 degrees Fahrenheit, was the coldest of the month. There's also one morning in 2014 that falls in the 5% warmest January mornings, and that was on January 11th, when the mean temperature over the continental U.S. land area was about 36.6 degrees. So there was a lot of discussion about how January just seemed so much colder than average. But how frequent are the coldest and warmest January mornings when we look at the entire reanalysis data set over the 36-year period? Well, here's a chart showing the warmest and coldest 5% of days, basically the 95th and the 5th percentile rank of days back to 1979 over the land area of the continental United States. In the first 18 years of the record, from 1979 through January of 1996, there were 38 January days that fell within the 5% coldest and about 20 days that were in the 95 percentile rank of warmest days for the month of January. The occurrence of really cold January mornings over the continental U.S. has dropped by nearly 50% over the last 18 years when compared to the period from 1979 to 1996. It's no wonder that this past January seemed unusually cold, because the last January with more than 4 of the coldest mornings coming on the same month was back in 1997 when there were 6 mornings. So it's been a while since we've seen cold mornings like we saw this past January. As a result of the cold air that was locked in place across much of the central and eastern United States and the Great Lakes and Midwest, we saw that there were areas particularly vulnerable to bouts of winter weather across the south. One of the more significant events occurred across Alabama and Georgia at the end of the month as moisture was transported back north across this deep cold dome anchored over the region. There was a swath of accumulating snow that led to a commuter nightmare from Birmingham to Atlanta. This event had huge impacts, as many of you may remember. I won't go into all the details, but it was the presence of the cold air mass and its persistence over this part of the country that contributed to the events that we saw, and they even continued into February and March into some of these areas. So there's the state ranks for the month of January as far as temperatures go. The West was an anomalously warm area, but much of the eastern United States was well below normal. No record lows for the month of January. And there's the traffic mess in Atlanta, nearly frozen Niagara Falls, and a little graphic in the lower right here that I put together at the end of a midnight shift on January 6th, showing the 103-degree difference in Fahrenheit between northern Minnesota and Miami, Florida on that Monday morning. That gradient of temperature is what got me started in looking at the longer-term record. So in summary, the Midwest and Southeast definitely felt the brunt of the coldest January in many years. Thousands stranded by the Dixie winter storm from the 27th to the 29th and even into early February, another bout with winter weather, and few January mornings with record cold in the most recent 2 decades. Well, on to number 2 here. As already mentioned, the large-scale pattern over North America this year featured an anomalous ridge of high pressure over the eastern Pacific and adjacent areas of western North America, and a downstream deep trough across central Canada and the Great Lakes. This is shown in the lower left here of this slide, and the pattern contributed to drought conditions in the West, with California being especially hard hit. The 12 months from February 2013 through January 2014 were the driest 12 months in the long-term record back to 1895. The persistent and extreme dryness resulted in one of the most severe Palmer Drought Index values for California in history, and the map in the upper right shows the total lack of precipitation over the state at the beginning of 2013. So let's take a closer look at what's happening, continuing to affect, well, up until recently, bone-dry California. From the closing months of 2013 through January 2014, it was the driest 3-month period on record for California in 119 years of record. And the chart there shows the time series. Here's the time series chart from the late 1800s through the 2000s, showing that there have been other dry periods across California, especially in the 70s and the 1990s, but this past winter was the worst and sets a new low for total precipitation over the state. And that was this bottom value right here, basically 0 precipitation. These maps show the rapid worsening of the drought conditions from January through the end of February. And during January, much of the state was already in extreme drought, but by the end of February, the exceptional drought began to expand across the central part of the state. And the city of Fresno here, represented by the star, is kind of near the epicenter of the driest area through this period of the year. And let's take a look at temperature and precipitation measures for Fresno as the year continued. So this is what's called a Haywood plot from the National Climate Data Center, and basically just showing a summary of precipitation as you go through the year. This chart here from January through July. And you can see for every year back to 1948, where 2014 lies, this is the blue line here, compared to the normal over this relatively long-term time series here, record. So the normal curve in gray, about 8 inches of precipitation for Fresno through July, about half of that falling during 2014. And you can see the very, very extreme low precipitation at the beginning of the year here, January, some reprieve, but really not enough to make much of a dent in the drought. And here's the Haywood plot for temperature for Fresno, California through July. And what's very disturbing about this is that 2014 is on record to be the hottest year in this part of California, at least back to 1948. And even more disturbing, perhaps, is that the second hottest year was just last year, 2013. So what happens during a drought is the dry conditions sort of beget the heat. And so the drier the air, the drier the ground is, the hotter the temperatures can become. And they don't cool as much during the nighttime hours. And basically this starts bootstrapping itself into being a real problem. And indeed, it's been a big problem across California. There's a comparison of what a difference a year can make between 2013 and 14 as far as the snowpack in the Sierra. And then we've all seen the pictures coming out of California of the low water levels across the state. That's Lake Oroville north of Sacramento. It's been going down fast in recent months. And hopefully some reprieve with more recent weather. So in summary, the period 12 months ending January 2014, the driest on record, more California in extreme drought than ever before by July, and at least $1 billion in agricultural losses. And one thing that you may not think about, but hydroelectric power generation is about 50% of normal, given that there's very little water flowing through the rivers to generate power. On to number 3. Well, those of you who followed these talks perhaps over the years, I make a point of including a nor'easter, if I can, in the talk, at least one nor'easter every year. I grew up in New England, and these storms are what really got me interested in meteorology. They're fascinating to watch. This one was not as close to the East Coast as typical nor'easters I've detailed in the past, but it was extra special in terms of atmospheric ferocity, and I decided it deserved a closer look and have its own entry in the year in review. So this is kind of a ping-pong loop here. Hopefully it'll display correctly over the internet, basically showing the development of low pressure over the northeast Gulf of Mexico, and then that low pressure tracking up along the eastern seaboard, just offshore, not as close as some of the traditional classic nor'easters, a little bit farther offshore. And this also perhaps a function of the colder air mass being shunted a little further east from the east coast. But this system, the pressure associated with this low pressure system dropped precipitously and over 52 millibars in 24 hours, and considered a cyclone bomb, or a bombogenesis as it's known in meteorology terms. And here's a loop of color-filled surface pressure from the SPC mesoanalysis, just showing the evolution of low pressure off the eastern seaboard and the remarkable drop in pressure and the increase in the pressure gradient, bringing intense wind speeds to parts of extreme eastern New England, and also this system had a dramatic impact on the maritime provinces in Canada. Here's the 24-hour forecast map from the Ocean Prediction Center depicting a 954 millibar low pressure center east of Cape Cod and south of the Bay of Fundy. And that was valid for the evening of March 26th. And then the mesoanalysis graphic on the right depicts the surface pressure change. And about 50 to 55 millibars in 24 hours is a dramatic drop in sea level pressure that occurred with this storm. And there's a forecast in the upper left here, the 48-hour forecast for the system, along with the maximum surface winds indicating 75 knot winds, basically a hurricane force winds in what's called a sting jet in the southwest quadrant of the intensifying cyclone. The satellite detected wave heights were monstrous at nearly 50 feet. And for reference, that's about 5 shipping containers in height. And that's what the pods are doing there, to put some reference on those wave heights. And the diamond marker here off the coast of Maine is actually the buoy that's located about 30 kilometers southeast of Jonesport, Maine, in the mouth of the Bay of Fundy. And this meteogram in the lower left shows the wild ride you would have had on this buoy, with air pressure dropping 30 millibars in about 12 hours and winds gusting to about 100 knots or 50 meters per second. Again, the main U.S. impact with the storm was kept to extreme eastern New England, blizzard conditions across Cape Cod, but it was a fascinating storm to watch nonetheless. So in summary, just a classic Atlantic storm system, well forecast. Hurricane wind field similar to that of Sandy, as well as the pressure that the storm dropped to, similar to Hurricane Sandy back in October year before last. So number 12, we'll go on here to the tornadoes returning to parts of the southern United States at the end of April. We'll take a look at this Sunday, April 27th, into Monday, the 28th of April, which is multi-day outbreak. It was definitely one of the bigger tornado events of 2014. As I said, it was a multiple-day event, actually 2-day severe weather outbreak that stretched from Sunday to Monday, and then this was the first time since November 1992 that had 2 consecutive days with killer tornadoes claiming more than 10 lives each day. We think that the April 27th, 2011 outbreak was significant, and it certainly was in terms of fatality totals, but an interesting aspect was that there was a break between the large fatality totals in that year. The last time to see killer outbreaks of this magnitude on 10 deaths or more each day was November 21st of 1992, when 12 fatalities occurred on consecutive days. The summary map shows the event continuing across North Carolina on Tuesday, and also major flooding over the Gulf Coast states as the large-scale frontal system stalled over the region going into the beginning of May, and we'll have more on that event in just a minute, but let's not get too far ahead of ourselves. Some of this talk has some detailed meteorology in it. I hope you don't mind that. This is a depiction of the composite chart with the water vapor satellite image beneath it, showing a strong upper-level jet, 70 to 80 knots coming out across Texas. This is valid for Sunday afternoon on the 27th. And this was a sounding taken, an upper air sounding taken at Little Rock, right before tornadoes occurred near and northeast of Little Rock. This sounding depicts the environment very favorable for tornadic supercell storms, and that's exactly what happened during the evening hours as a warm front lifted back up across central and northeast Arkansas. On the following day, another composite chart here showing the system beginning to evolve eastward, moving toward the Mississippi Valley. The base of the composite chart here, instead of being the water vapor satellite, I've included the radar image here. And this situation, perhaps even more volatile on Monday, the 28th, as instability across Mississippi was extreme. And you can see the sounding here from Jackson, Mississippi. Again, a proximity sounding just prior to tornadoes occurring. With classic conditions, plenty of instability in the sounding, and the wind shear intense and supportive of strong supercell storms and possibly long-track tornadoes, which is indeed what we saw. So in Valonia, Arkansas, on Sunday the 27th, this was the first EF4 tornado of 2014, the first one in the U.S., and only the 3rd such tornado in Arkansas since 2000. Arkansas has never experienced an EF5 tornado. And unfortunately, parts of southwest Valonia, this area of Arkansas, which you can see by the star here in the upper right graphic, has experienced a number of strong to violent tornadoes over the years. The last strong tornado was a 51-mile track tornado in April 25th of 2011. And since reliable records began in 1950, Valonia has actually had 5 other tornadoes track through the present-day city limits, a kind of an unfortunate occurrence. Most of Arkansas's tornadoes occur during the month of April, and unfortunately, Valonia is not in a very good spot. And then the bottom image is here a before and after image from Mississippi, from Winston County, Mississippi, from a long-track 34-mile EF4 tornado that occurred on Monday, April 28th. And that's a picture of that tornado, an amazing shot taken from central Mississippi on April 28th. So in summary, the tornadoes return, and this event was one of the larger events of 2014, and we will see probably a total of 70 tornadoes occurring with this event, 34 fatalities and numerous injuries and about $500 million in property damage. Bologna, Arkansas hit by the EF4 after an EF2 in 2011 and the 5th tornado since 1950. As I mentioned earlier, the Gulf Coast received quite a soaking as the frontal system stalled over the region on April 30th, and really the heavy rain continued right into the beginning of May. Really insane amounts of rainfall here, especially in areas from Mobile Bay to Pensacola, Florida. So let's take a closer look at this. We're going to zoom in on this area across the Gulf Coast region from the southeast Louisiana up across the western part of the Florida Panhandle. And here's an infrared satellite image showing enhanced cloud tops. Cloud top temperatures here, the colder they are, the more impressive the color signature, minus 80 degrees C here at the very top, and the higher the cloud in the atmosphere, the more likely it is to be producing copious rainfall. And this system basically, we overlay the lower and upper level winds. This was what we call a mesoscale convective complex or system that was back building, and then the storms were training over the same area from Mobile to Pensacola here, basically this region here. And the hydro estimator technique, which takes the infrared imagery and tries to depict the rainfall amounts possible using some model data here, did a pretty decent job in showing the centroid right around Mobile Bay and points east. Not quite as extreme when looked at by radar. The actual rainfall amount's just a little bit higher than what was estimated by the hydro estimator, but it got the area right. Here's a 36-hour storm total loop from the area, and you basically saturate the color scale here at 15 inches of rain. And in the end, Pensacola had over 20 in 2 days. That's just way too much rain over the land areas, and it resulted in quite a bit of damage. In fact, even an explosion at the Escambia County Correctional Center resulted in some deaths there, most likely a result of flooding in the basement, disconnecting industrial strength dryers in the basement of the prison, and then those dryers, the gas lines being cut and gas leaking into the basement and then exploding. Lots of schools out because the roads are damaged, and quite a bit of damage to this part of the country. Some of the summary rainfall amounts: Pensacola had almost 6 inches of rain in an hour, and a new 24-hour rainfall record of approximately 16 inches. That's an estimate because their tipping bucket rain gauge lost power. Their records go back to 1879. Gulf Shores swamped with a foot of rain in 9 hours. Mobile, Alabama, about a foot in 24 hours. The third greatest rainfall on record for Mobile, their records back to 1871. And fascinating that the system really was not associated with a tropical storm, which usually brings copious amounts of rain. On to event number 6, memory number 6, I've titled Nebraska Nasty. It was a definitely nasty June in Nebraska, with a lot of severe weather. It seems like they've gone a few years without significant severe weather, so this one really stood out. And actually there are events in June for strong tornadoes. About a normal June would have about 2 days with an F1 or stronger tornado during the month, and this year they had 4 distinct June days with F1 or stronger tornadoes, and normally about 6 to 7 days with giant hail of 2 inches or greater reported in June, and this day about double that, about 12 to 14 days with a report of hail about 2 inches or greater. So let's take a look at a couple of these events. The first one, June 3rd, is quite memorable for me as I worked this event as a lead forecaster, filling in on the lead forecast desk at SPC. The tracks on the right are the radar estimated hail size, showing extensive swaths of about 150 miles in length where hail was in excess of 2 inches in diameter. This event produced a tremendous amount of damage across parts of eastern, southeastern Nebraska and extreme southwest Iowa. Lots of damage to homes, cars, and windows in this area. Some estimates may be approaching $1 billion here in losses. So certainly one of the bigger monetary losses from a hazardous weather event in 2014. Just a few days later, across northeast Nebraska, an interesting event with respect to tornadoes. And on the right here you see the long-term climatology, 1962 to 2011. These are all tornado tracks occurring within about 125 miles or so of the radar located here to the northwest of Omaha. Interestingly enough, we come around to June 16th and we add to this in an area that had kind of a bit of a minimum in terms of EF4 tornadoes. 4 EF4s occurring across this area of northeast Nebraska on the afternoon of June 16th. And if you look at the long-term record of when tornadoes are most likely to occur in this part of Nebraska, sure enough, we're right at the peak. So climatology would suggest that if you're going to see big tornadoes in this area of Nebraska, middle of June would be the time of year. This is a detailed map here on the right from the National Weather Service office in Omaha showing the tracks of the 4F4 tornadoes. And this was the day of the famous twin tornadoes of Pilger, when the town of Pilger was hit pretty hard by the EF4. Pilger here and then its twin off to the east. And I've got a radar animation I'm going to show next here with all of these tornadoes, and you'll see the circulations associated with the tornadoes, and then we'll focus in on the merger of these two tornadoes that occurred right around 4:30 in the afternoon. So let's see if we can get this to run. On the right is what's called the correlation coefficient. This is also known as a debris signature associated with the winds. And on the left is the velocity information, red being winds that are approaching or going away from the radar, green approaching the radar. And so you can see the radar is located to the southeast here, and you can see the circulations associated with the tornadoes here. And then we'll see one more tornado that is called the Wakefield tornado that will head off to the north here. And then we'll take another look at this. We'll slow down and we're going to take a look at the merger of the two. And I prefer to look at the debris signature here because you can really see kind of how the vortex evolves just from Pilger on to the northeast. You can really see the two spinning around one another there, what we call the Fujiwara effect, and then it just goes back again and forward again. Fascinating event. Unfortunately, the town of Pilger almost destroyed by this tornado. 3 fatalities associated with the tornado in Pilger, and 4 F4s in a day. Very unusual event. There's some of the damage from the hail occurring back on the 3rd of June there, wind-driven hail. You combine dangerously large hail with 80-mile-an-hour winds, and that's what your house might look like after the storm goes through. Unfortunately, the twin tornadoes of Pilger producing a tremendous amount of damage in the small town there in northeast Nebraska. We'll probably have to up the figure in damage on June 3rd. And then a new record for severe hail reports across Nebraska in June, and the 4 EF4s causing millions in damage on the 16th of the month. Number 7, did it seem like a cool summer where you were? Well, here in the central United States, it kind of seemed unusually cool. And I wanted to, again, take a look at what our perceptions were with respect to the longer-term record of temperatures during the summer months. The picture in the lower left there is an idyllic August day in Vermont, up in Vermont on an annual vacation, and it seemed to be absolutely beautiful, temperatures in the 70s and quite nice up there. But it was also, we had a couple of nice days here in central Oklahoma, too, right in the middle of July, which is putting July and nice days in the same sentence for Oklahoma did not seem all that natural. So the national rank for temperatures from June through August, if you look at this map, it's basically near average. Not too cool, not too warm, anywhere in particular, and that's just a broad average over the entire United States. But what I wanted to do is take a look at the continental United States with respect to the long-term record. And so here we have a chart basically showing the average temperature for each day over this part of the whole country, the lower 48 states. The summer average for 2014, about 56 degrees. And the daily, you see here, June, just about normal across the continental U.S. July had some ups and downs, and in fact, these were the days that were unusually cool across the central United States, but no new all-time records. That would be the blue line. Approaching tying an all-time record low temperature for the continental U.S. in the middle of July, but not establishing one. And then back to kind of a more normal record here for August. So this is really not all that unusual. There was one extreme, one new all-time high temperature for the continental U.S. on the 3rd of June, coincidentally the same day of the record hail event in Nebraska. So why did it seem like, at least for some areas of the country, it seemed cooler than normal? Well, only a couple years earlier, we experienced what I've been calling the summer from hell. And basically, many areas of the country established all-time high temperature records for days on end, especially in July. June of 2012, above normal, but no extremes. Then we get into the end of June, most of July, and into the beginning of August. We set all-time record high temperatures over the continental U.S. For the days, and then back to a more normal pattern in late 2012, the summer of 2012. So in hindsight, looking at the 2012 extremes, it's possible that we experienced 2014 as being cool when in fact it was normal. And if you look at the difference in temperature between 2012 and 2014, you see that 2014 was anomalously cool, or much cooler, across a broad section of the nation, the West Coast being an exception and a bit of the Southeast. But when we take the difference between the two summers, we see the dramatically cool weather that we experienced in 2014. But if you look at the long-term record, it's kind of subtle. It's more muted. There's no, in fact, in the central U.S., we were slightly above normal in the long-term record. The only areas of the country below normal in the summer months of 2014 were the Intermountain West here, and then maybe a small part of the Appalachians. And so I compared these records that I came up with in the reanalysis data to the longer-term record in state ranks from NCDC, and they appear to match quite favorably. And we had a couple of all-time cold months for the state ranks. Arkansas and Indiana having an all-time cold July, or record coldest July. But in the mean, everything, you take the 3 months in total and average them, and you get about an average summer. So it felt much cooler, but it really wasn't. It was about normal, and the West Coast being one sizzling exception. And speaking of the sizzling exception, we'll take a look at some western fire facts. It was a busy fire season on the West Coast, especially parts of Washington, Oregon, and Northern California. And they got the King Fire that was started by an arsonist late in the summer. And then the lower left image here, a fire, I can't quite remember the name on that one, on track to become the largest wildfire in the U.S. this year, and we'll talk a little bit more about some of these. So the onset of these fires began with what we call a lightning bust across Oregon and Washington on July 14th. This is when high-based thunderstorms move across these areas and ignite wildfires because conditions are ready and so dry. And so I'm going to loop this image here and show you how the wildfires basically began and then spread. You won't be able to read the individual names that are given to the fires, which are the red font on the image, but the yellow areas are areas of fires. And we'll start the loop here at the beginning of July and continue it on through September 24th. So you should be seeing it loop now. And you see some big fires blowing up here. These are all lightning caused for the most part. Even the complex here, a Happy Camp complex in Northern California being lightning caused. And then at the very end of the loop, you'll see the King Fire here. I think it's just to the west of Lake Tahoe. There's the King Fire starting. So those four were the biggest fires. The Carlton complex in north central Washington, the Buzzard complex in eastern Oregon, Happy Camp in Northern California, and the King Fire in central California. And if we look at the acreage, pretty amazing sizes to some of these. Luckily, not a lot of property, although there was some considerable property damage in California, mostly the Washington and Oregon fires occurring in quite remote locations. If we sum up the total area of just these four fires, we get about the size of the state of Rhode Island. So pretty large area burned just from these four. And there were many other fires in the West this year. And you can look at wildfire activity level in any year by taking the average wildfire size. So you take the total acreage burned and divide by the number of fires, and you come up with the average size of the fire. And we see that in 2014, while the data is incomplete, it's actually the second largest average fire size on record back to 2002. And this is just for California, Oregon, and Washington combined. 2012 is a year that's going to be hard to beat, and let's hope we don't do that anytime soon. But certainly 2014, a very busy year for fires in the West. And not only the wildfire activity straining resources, but air quality very bad across much of the West, visibility very low too across parts of the Rockies and areas that you'd like to have better visibility in the summer, but not this year. On to number 9. This is an addition from the talk that I gave at the NWA. I actually ended the NWA talk at number 8 because I couldn't come up with a 9 or a 10. So here's number 9, and it's pretty straightforward. We just went through an incredibly cold month of November, and we saw some amazing snowfall across the Great Lakes. And it's kind of hard to believe that the large-scale pattern is connected in such a way that the super typhoon Nuri, one of the strongest storms ever observed on Earth in early November, contributed to a dramatic buckling of the large-scale wind regime, the large-scale jet stream across the northern hemisphere, resulting in a river of incredibly cold Arctic air streaming due south into parts of the north central and central United States, and also in the east. And so it was this hurricane and super typhoon and its influence on the large-scale flow that actually resulted in lake effect snow of record amounts. This loop is a loop of the upper-level jet stream I just talked about for the entire month of November. And basically here you'll see how the upper-level ridge basically is dramatically pumped up here, record high pressure across western North America. And as a result, you basically set the jet stream up to take cold air from the Arctic reaches and bring it due south across the continent. And so this ridge of high pressure was a very persistent feature, especially at the beginning of the month, but basically wanted to continue right on through most of the month. We'll run this one more time here. So this is November 7th, and really the ridge starts to develop around the 9th or 10th, and it remains in place through the middle of the month. And it's this cold air streaming south over the warm lakes at this time of year that can really bring incredible amounts of lake effect snow. Just another look at the anomalous nature of this high-pressure system pumped up by the decaying tropical or typhoon system. This was valid for November 13th, showing that high-pressure values in the upper levels of the atmosphere are all-time highs for this time of the year. Now, I put this map together again from reanalysis data comparing the entire month of November to the 35-year climatology, and we are in second place. If you look at the long-term 36-year climatology, November 2014 places second as the second coldest November across the continental United States. The coldest November on record using this data set was November of 2000 with an average temperature of about 38.5, so about half a degree cooler than this past November. And of course, the lake effect snow downstream from very warm Lake Erie was epic. And you can see here a neat plot put together by a colleague of mine, Dr. Karstens here at the Severe Storms Laboratory, using composite radar reflectivity showing the total number of hours out of 6 days with reflectivity values in excess of 20 dBz, so relatively heavy snow indicated on radar on 3 solid days out of the 6 days that this composite is made of. And it really was 2 events, and it was pretty difficult to keep track of how much snow was falling at any time. If you were looking south from western New York around the Buffalo area into this band during the event, this is what you would have seen. And it's a remarkable image showing, just a still image, but you get the idea of the updrafts and the strength of this convective snow. Basically, it's the atmosphere boiling up out of the warm lakes because the air aloft is so cold, and then dumping snow in incredible amounts just as that moisture moves downstream and across the land areas. And it wasn't just Lake Erie. You can see in the upper left here a composite of numerous lake snow bands coming from Lake Superior, Michigan, Huron, Georgian Bay, Lake Erie, and Lake Ontario, all active in this event because the air was so cold and the lake waters unfrozen and still so warm. One of my favorite pictures is this person opening their garage. Where do you even start with snow amounts that heavy? And then also this picture from airline approaching Buffalo at night and showing the lake effect band basically in place. Remarkable amounts, and you go 1 mile, you got no snow, you go 5 miles into this band, and you've got 7 feet of snow. Just hard to believe that the atmosphere can do something like that. And it's due to teleconnections, and it was the second coldest November in 36 years, and then of course the epic lake effect snow as a result. That's event number 9. Number 10, we're going to leave open as a question today. There's a few days left, and not that I don't have something decided already. I'll give you a hint. This event will not be in chronological order, but this will be a highlight of the entire year, and I will provide that information to you if you're interested. Memory number 10 will be revealed and described on December 29th at 8:30 in the evening Central Time on the show Weather Brains, the internet weather show with James Spann and Bill Murray. So I've agreed to go through all the memories again, and then we'll talk about event number 10 at that time. And those are the 9 events of 2014, and thanks very much for joining us today. It's always a pleasure to give this talk to those who are interested in weather, and I always invite you to send me your interesting events, significant events during the year. Not guaranteed to get in the talk, but I like hearing from other folks that are also interested in these events through the year. So thanks again for your patience in listening to the talk today, and I'll pass it back over to Henry.
Thanks, Greg. That was really interesting. A lot of different ones there that some of us will remember from the year. In fact, the Gulf Coast Soak one, we had a lot of CoCoRaHS volunteers in the Mobile and Pensacola area reporting those large amounts as well. And so that was really neat how that was tracked. We'll take questions. If you guys have any questions, go ahead and type them in. Greg will have a little bit of time here to answer those for you. I've got a question for you. You had a really neat example of tornado climatology with the lines over a period of time in the Nebraska example. Are those available online at all?
Yes,
I mean, not
they
just
are.
that specific one, but for others.
Yeah, if you go to the website there, www.spcnoaa.gov, and I believe it's under, let me check here real quick, I think it's under Forecast Tools. It's either Forecast Tools or Storm Reports that climatology is available through our website.
Okay, we'll put
it's
that
called
link.
The Tornado Environment Browser.
Oh, good. Well, we'll put that link on our website as well, and we'll have this posted, this broadcast, and hopefully some of Greg's slides that you can go back and look at from there. Okay, folks, well, we haven't had any questions. Anybody out there have a question? Oh, here we go. Here we got one coming in, and so Maggie writes in and wants to know, how is hail size predicted from a radar image and from the data? How are they able to do that?
That's a great question, and there's been ongoing research here at the National Severe Storms Laboratory. For many years, we've got a program called SHAVE, which is basically trying to contact individuals in the area where storms have just passed and to try to correlate what they have on the information on radar. Of course, the radar now is so sophisticated, I call it a CAT scan for the atmosphere. We're basically slicing the atmosphere up and looking at different layers. And from those different layers, we can see the intensity of the storm, both in terms of its rainfall, but we can also now, with dual polarization, tell whether we're looking at raindrops or whether we're looking at hail. And a collection of this detailed information about the radar imagery over many years, when you do ground truth, has given them the ability to come up with algorithms or programs to basically decode what the radar shows and give an estimate for the hail size. So that was what we call the MESH product, and it's the maximum estimated size hail summary, and we have those available to us both every 5 minutes and then summary charts for the entire day.
Thanks, Greg. You know, something that's come up, I've talked to folks with the cold January last year and stuff, we hear this term polar vortex, and the media's taken that and really kind of run with it, and oh my gosh, the polar vortex is coming. Can you just talk quickly about that a little bit?
Well, as we saw a couple of these charts that I showed, especially the one for November, the atmosphere is wavy, and it has it's constantly in motion. The atmosphere is an ocean of air, just like the ocean has circulations and rivers associated with it. The Gulf Stream off the East Coast, the atmosphere behaves in very much the same way, only a little faster because air is less dense than water. And it's these waves in the atmosphere that actually produce weather. So a high-pressure wave, the air is sinking, and a low-pressure wave, the air is rising and causing the storminess. And the polar vortex is actually kind of a semi-permanent feature associated with the circulation in the northern hemisphere. And it's associated with rising air, but also very cold air. And and it moves around. It doesn't stay always over the poles. And in fact, this time of year, it can dip south. And actually, if you look at the weather map today, you'll see a large circulation over the northeast United States, kind of a trapped whirlpool of air up there. And so, it is semi-permanent, and actually it's not inaccurate to describe the polar vortex and its influence on cold air outbreaks, but it does move around and sometimes goes away and sometimes comes back, and there's really nothing all that unusual about it. It's part of the atmosphere. It's part of the circulation pattern in the northern hemisphere.
Thanks. We're still open for questions if anybody has any. One thing, watching your presentation today, two things that really struck me as being absent. We hadn't really seen much on hurricanes this year, and large many tornado events. Could you speak to that quickly?
Yes, and I don't want to give away too much, but maybe the tornadoes, the lack of tornadoes this year is very unusual, and we're still scratching our heads over that one, putting together some information as to what might describe better why there was a lack of tornadoes this year. This is the third year in a row with well below normal tornado activity in the United States, following one of the busiest or record years of 2011. In what appears to be the case, and there's no similarity in the weather patterns across those 3 years. So for different reasons over the past 3 years, we've had low tornado numbers, and trying to sort that out is no easy task.
And for hurricanes, similar. How many hurricanes did we have this season? I can't recall.
Did not have a summary this year. We only had one that made landfall, I believe, on the East Coast.
Yeah, it was like July 4th, right? Yeah.
Yeah, in July. And again, the connections are difficult there because it's not just one thing. It's not just the fact that the shear is stronger or the ocean is not as warm or something that keeps hurricane activity suppressed. I think that's what's wonderful about meteorology and climatology is there are many, many mysteries yet to be solved.
Well, Greg, I want to thank you for doing this and coming back this year. Maybe we can have you come back again next year. Again, this is a really neat tool to look back and jog our memories of what's happened during the year over the country. Really appreciate that, and so we want to thank you and our colleagues here. We're getting a couple questions. Let me jump on those. If you have time here, we'll go through those.
Sure.
So Steve writes, and these are both, I guess, Steve and Pardee both writing against the Northern California storm today. What are your thoughts on the storm hitting today? And then Pardee wants to know, why are there so many Pacific tornadoes? His question was. Why were there so many Pacific tornadoes?
Well, yeah, I did a chart yesterday on, I'll answer the last question first. I did a chart yesterday on the deficit, or actually the anomaly of watches that SPC has issued this year. And one thing that stood out there is actually there was more activity than normal in terms of watches in the western U.S. This past year. The storm system moving along across the west coast today is fascinating, especially with respect to the wind fields associated with it. Of course, the higher elevations will get some incredibly high winds, 80, 100 miles an hour in some of the Sierra Crest region, and then I'm really looking forward to the heavy snow because they need it. And so the snow is going to be tremendously beneficial with this system. And let's hope that this is a pattern that is becoming established for the winter. This would be the time of year that the pattern would start to become established as we go into December, and it's quite possible this will be the first of a number of storms. Another back to the western tornadoes. I think also a function of population. I think you have more people, and so the numbers of events that are being reported are perhaps a bit higher than they might be in the past, just because there are more people out there and there are more people weather aware.
Okay, thanks. Well, again, we thank you for being with us today, and Greg for doing this for us. We'll post some stuff on our website on this, and so if you guys want to look at that, it'll be great. And we want to, for you guys, folks out there on the broadcast today, want to make you aware of our next Weather Talk webinar. And this would be a very interesting one. It'll start on Thursday, January 22nd. So if you'll mark that on your calendars, Simon Troutman, he's a national avalanche specialist with the U.S. Forest Service National Avalanche Center in Bozeman, Montana. He's going to talk about avalanches across the U.S. And a fascinating talk on that, what causes them, their frequencies, and so forth. So look for a announcement on that, and we will come back at that time and have our broadcast then. Well, also remember to take a short survey at the end of today's webinar. And again, this is Henry for the Climate Center here and the rest of the folks at CoCoRaHS, wishing you a good day, and thanks for being with us.